So
thank you, Brian.
take it away. Would you like this one or that one?
I'll take this one. Okay, this presentation is about CloudSim. CloudSim is a system to run a simulation and ROS on the cloud. After a brief introduction, I will walk you through CloudSim, then show you why we're building CloudSim for the DARPA challenge, then take you to the evolution, how we build it, the way we build it so far, where it's at now, then touch on the limitations and benefits and the future possibilities. So, the best way to know about CloudSim, well, first of all, CloudSim is a collaborative effort. It's mainly built by myself and Carlos Aguero at OSRF, but we also have Brian when he's available. He's very helpful on the project, as well as Steffi, our user interaction designer, and Brent Reville, who works in Spayware, and he's kind of our skinning expert and web guy. So, the first step about CloudSim is to log into CloudSim, and it's an easy step because you can use your OpenID credentials, so you don't even have to create a new password. Second step is to set up your cloud's credentials. So, CloudSim uses Amazon. We started off with Amazon, but recently we've rolled in another cloud provider, a smaller cloud provider called SoftLayer, and we may even add more, perhaps StormPath in the future. And basically, once you have your credentials in place, then you can launch what we call constellations, which are a group of one or more machines arranged in a private network in the cloud. Now, this step takes about 20 minutes on Amazon servers to about an hour on SoftLayer, so it takes a while. But once you're done, you get your machine you get your machines in the UI, and you can see the latency status of the machines, and then you can download keys and establish a private network directly to them. So once you've got your system, you can then set up a simulation task through the web interface and basically just set up a ROS package or a ROS launch file. There are more options here for the VRC. You want to be able to maybe set an artificial latency for your communications and maybe limit the bandwidth. Once it's all done, you can press start, and then you can connect from your local machine to the machine living in the cloud. This is an image from one of the VRC qualification arenas, and that particular robot lives in Virginia. It was launched on the Amazon cloud from California with about 100 millisecond latency round trip, and it runs at about 0.75 real-time factor. So, why did we build CloudSim? We built CloudSim for the DARPA Robotics Challenge. DARPA has a vision that eventually robot will replace human in dangerous situations like the Fukushima disasters, and will actually be useful there. In order to accelerate the process, they've designed a two-phase challenge, which will involve real walking humanoid robots. Now, we're right about at the middle of phase 1, and there are about 100 teams that have registered as Team Without Robots, and we're going to use CloudSim and the Gazebo simulator to basically find out which of the teams will get a money to partake in the next challenge, and one of the 6 Atlas robots by Boston Dynamics. This is going to happen by the end of June. This is the Atlas robot and the sensor head, and on the right you can see what it looks like in the Gazebo simulator. We have different tasks for manipulation, dexterity, mobility. And basically, what DARPA is trying to do is a kind of a map reduce of the best teams. And by the end of this month, CloudSim should launch about hundreds of servers in the cloud to control simulations. The teams will have those for almost a month, and during the last week of June, they'll each have to go through 15 tasks in 3 days, and we'll measure their performance based on the time, the task completion, and also bandwidth utilization, because in normal disaster simulation, disaster scenarios, I should say, we expect bandwidth to be limited. So the contest itself will probably involve operators running in a building close to the site with a tether, and the bandwidth is going to be artificially controlled through a black box. So to recreate this environment in CloudSim, our constellation has 4 machines: the router, which does the bandwidth control and inject the artificial latency. And then we have 3 machines, which are 3 large servers that run on a 10 gigabit backbone. One of those servers hosts the simulator, and this one is off-limit to the teams. It has a Tesla K10 GPU, and the other 2 servers are for the contestants. They can put whatever code they want. One of them has a GPU, the other one has extra memory and a SSD drive. So, how did we get to where we are now? So, when I joined OSRF in September, Brian already had a prototype that was able to launch a machine on Amazon services and set up a X session, install Gazebo, and this was all behind a web server that you could log in through OpenID. So during those times I was basically working on CloudSim on my own, and I rewrote the web interface to add a REST API and added a Redis backend to do the communication between the web server and the part that controls the machines. And I added a push notification service to get demands, to get updates from the different machines, like the latency and stuff like that. This turned out to be a very bad decision because the push notification system I used was actually not very good on Apache, and we reverted to a polling scheme since then. So by February, we needed to implement the multi-machines. At first, we decided to just chain private networks between machines. So, for example, when you log in to your constellation, we have you log in through an open VPN private network on the other side. When you have multiple machines, a field computer that then connects to a simulation computer, we could chain multiple virtual network, but that becomes a problem when we have 3, 4, or 5 machines. So we had to use, we decided to use Amazon's virtual LAN system. And the virtual LAN allows us to have a private network for all our machines inside the constellation, but it is significantly different from the normal AWS system. So I decided to rewrite the backend using, instead of single threads per machine, use a different system where basically a single threaded system where you could plug it, where constellations became the plugin rather than machines being a unit of composition. So if you want to have a new plugin, a new constellation in CloudSim, you'd need to provide a Python script that provides a way to launch the machine, a way to terminate your machines, and a way to monitor them, and also start and stop simulation tasks. One of the interesting things about working on a cloud infrastructure is that machines take time to boot, and actually on Amazon, bringing a machine up takes about 20 minutes, and that severely impacts your programming ability because you only have that many cycles during a day. So it's a good exercise to change your habits there. So, but not all is wrong. And in February, Steffi, our UX designer, made a little contest. She created a few logos for us, and CloudSim had its logo. By that time, we were starting to actually use the machines on the Amazon cloud, and we were noticing strange behaviors. We weren't getting the bandwidth, the full 10 gigabit bandwidth between our machines, and also the change from the separate machines to the virtual LAN made it so that we were using machines from a pool that was very limited in size, and it was the only place on all the Amazon data centers where we could actually get virtual LANs and these GPU machines, and we started getting capacity issues, meaning that they had too many clients for the number of machines they had. We were chasing weird issues while making loops, control loops from different machines. So you have the simulation running the robot controllers, but you also have the field computers that run the Teams controllers, and they try to run at a very high frequency loop. And what we see here on the left is that on a normal machine, this is running a small program that just sleeps for a millisecond and then measure the time it took since the last sleep. And we see that normal sleeps are normally around 1.1 milliseconds, and from the outliers are in the 1.5, 1.6 millisecond range. However, on the Amazon machines, we were getting outliers that were all the way up to 300 milliseconds. And when you have two machines trying to do a very fast loop, this is a very huge problem. So we decided that we should go for a different provider for the VRC, and we contacted SoftLayer. SoftLayer already had given us machines when we were having capacity issues, and basically the machines that SoftLayer provide are basically newer than the Amazon machine. They have recent NVIDIA processors and some of the fastest Intel Xeons available. Also, there are absolutely no hypervisor on these machines, and which is probably why we were getting these issues, these hiccups in the first place. Unfortunately, the SoftLayer machines are month to month, unlike the Amazon machines where you can lease them on an hourly basis. You need to commit for a full month. Also, the SoftLayer machine don't take 20 minutes to load up. They take an hour, which is even worse. And also, we had several problems related mostly to Ubuntu, the motherboard, and some of the Ethernet cards they're using over there. So, where's CloudSim now? Well, CloudSim itself is the architecture itself is kind of stable now. We have a web server that talks to the client, and all the control for machines, bringing up machines, measuring latency, and everything is done through a daemon. And the communication between the daemon and the web server process is done through Redis. Redis is also used as our backend store, and the communication with machines themselves is either through the cloud provider's proprietary interface to load them up or to control the firewalls, or it's through SSH once the machines are up and available. So, limitations. So, I'm very interested in seeing cloud robotics as something that could take off and really be important for the robotics field, but there's always the problem of there's always a network between you and the cloud, and latency is one of the major issues when you're dealing with the cloud robotics. So if you intend to do control loops on your machine, you need to connect to a data center that's really close by and make sure you have a good pipeline in between. The other problem is cost. So I guess normally in labs, people already have computers or they're paid for and they seem to be free. Once you start using the cloud, you're paying on an either hourly or monthly basis, and this could be expensive. Also, the cloud doesn't really have a lot of GPUs available. Amazon is pretty much the only game in town if you want to rent a GPU by the hour. Others are coming, and we see that NVIDIA, they're preparing products for game streaming, so this should be useful for robotics as well. And hopefully in the future, we'll see cheap GPUs available at maybe 50 cents an hour, and maybe by the end of this year or next one. So, what are the benefits? Well, if you've ever had problems installing ROS or Gazebo or anything like that, I think it's great to be able to leverage the work of others to get a working system in a very little time. I hope to see a lot of more flavors of what's available right now, so everything is pretty much DRC-centric, but it would be possible to have a lot of different constellations supported in the near future. Also, if you want to do concurrent work, let's say you have multiple graphs that you want to try, you can try 1,000 grasp or 10 grasp in the same amount of time. Also, having a system that works in the cloud makes things simpler, and then you can connect with a simple notebook, different OS, and etc. It's also a great tool for sharing, because once your data is on the cloud, then there's no little, the cost to sharing with other people on the cloud is very little. So I would like to see CloudSim as maybe a platform where people could store simulations and the work they've done. You don't have to write a wiki, instructions to set up all your required software. You can just freeze it in the cloud, provide a link, and then have somebody else see your work and maybe take it a step further. Also, well, right now CloudSim is very much for real-time simulation with a user in the loop, but I see that automatic testing, something like a Jenkins specific for robotics, could be very useful. Also, well, I guess because of its contest nature, CloudSim would be a good fit in the education sector. I could see a professor wanting to interest their student by creating a contest in a simple way. Well, as I said earlier, connect to existing data sets. So if we have grasping or object databases or benchmarks in different areas, it would be a great tool to have everything in the cloud and easily accessible. Finally, since we're making robotic software a tool to deploy robotic software, and its target is the cloud, we should use the same tool to target it to real hardware eventually, and I think that would be an interesting thing to explore. So, CloudSim, well, was created for the DARPA Robotics Challenge, but we hope it's going to contribute to the success of Gazebo and ROS in general. I'd like to see it foster new workflows in robotics simulations, things that we've not seen before. And like most software at OSRF, it's open source with a BSD license. So we'd like to see it, I'd like to see it as a kind of the equivalent of Android, well, as Android is to Linux. And I would like you guys to help make the App Store full of interesting things. Thank you.